Good morning. Ladies and gentlemen, good morning. Good to see you all here in Cinemac, Ede, and welcome at the Luminis DevCon, the 4th edition. Who's here for the first time? Welcome. This year, more than 20 sessions. More interaction, more entertainment than ever before, so we are really confident that it will be a great day for you. And my name is Niels Houtepen and I'm an illusionist. Are there any questions about that? And in this role, I'm very happy to be your host for the next couple of 90 minutes. First of all, a few general announcements. At the back side of your name tag, there is a QR code. And please use this code, and it will guide you to the app, the DevCon app. It's a great app. And most important part of it, the complete program is on it. So use it wisely. And also please use it for voting after each talk. Around 15 minutes before the end of each talk, you can vote on the speaker. And the speakers are really happy to collect all the feedback from you. There is also a traditional way of voting. That's also important because it's your first feeling you can share with us. And you have the possibility to do that after each talk. At the end of the session room with the traditional and really famous luminous cards. Hey! This is the red card that you put in the bowl if you don't like the talk. Good to know. This is the orange card. Could have been better. Then you drop it into the bowl. And this is the green card. If you like it a lot, please put it into the bowl. So we hope to collect many green cards. Then, last but not least, be nice to each other. Please get to know each other and try to have some great conversations today. Are you ready for a great day? Are you ready for a great day? Before we can start, I would like to have a warming up with you, because when I talk to know each other, maybe I need to take the first step. To start, let's use a little bit of luck for some people. And one person in special. Can you all stand up? Because under your seat, under one seat, there is an orange card. Like a sticker, a post-it. If you've found it, please let me know. It's a big crowd. Is there somebody? Please make some noise. There? Over there? Okay, I will come to you. With this kind of meters, it's really a warming up. Hello, sir.
Hello.
What is your name?
My name is Mark Beckers.
Mark. Yes. Mark, my name is Niels. First things first, it's really important because I would like to try an experiment with you. And before we can start, can you please announce that you're not an actor?
I'm not an actor.
At least not an actor who is on tour with me.
No, not at all.
Okay, and this is the first that we met each other?
Yes.
Okay. Mark, are you a person who can easily see pictures in your mind when I ask you to?
Yes.
Okay. What I would like you to do is concentrate, not on the people around you, but on the vision in your mind. And when I ask you to focus yourself on a few simple objects, is that possible?
Yes, I can.
All right. When you have an object, please, yeah, be okay. When I snap my fingers, please switch between the objects you see. Is that possible? I do that a few times, and at the end, I will ask you to make a choice, a final choice. Okay. final time, last time, make a decision. Do you have one object?
Yes.
Concentrate on the object. Is it an object you use often?
Yes. Very often.
All right. Please, for the first time, out loud, what object did you choose?
I choose the light bulb.
And did you make a final? Was there? Wow, a light bulb. The kind of that I used.
Yes.
Was there another object you doubt about it?
Yes.
It's a warming up, guys. Sorry.
Yes.
What was the object?
The other one was a wine glass.
Wow. Thank you, Mark. Thank you. Let's go. Let's take it one step further from here. Are you a guy that's often in other countries? Do you like to travel?
Not so much, but I travel.
But if somebody today on DevCon give you the opportunity to make a journey wherever you would like to go,
Yes.
you will take it with both hands? Okay. This is your chance. In your mind, please go to a place somewhere in the world. Concentrate on it. Only on the place in the world. Everything is coming to me now. Okay. Are you there with somebody?
Yes.
Can you share with me the first letter?
The first letter. I have to think about it.
Yeah, you can tell us?
It's H.
Please, where are you at the moment?
I can say
Somewhere.
in Israel.
Thank you, Mark. This is a little gift for you. Okay, this is the old-fashioned way of knowing somebody, but in these days, on DevCon, the 4th edition, there is another way to do it. Is there somebody here in the front rows who has an iPhone I can use? Thank you, sir. Can you put your browser on? Please put it on Google. Not on Facebook. Thank you, sir. That's interesting. Okay. Because you only need to go to the history to know a lot of somebody. I will not share every detail of it. Maybe, can you join me on stage? Where are you? Come over here, please. What's your name, sir?
Martijn.
Martijn? Martijn, can you concentrate on a very famous person, somebody we all know?
Yes.
Okay. Can you put your hand on top of the iPhone? Thank you. And please announce for the first time the person you're thinking of.
Steve Jobs.
Steve Jobs. That's an interesting person. Is there any chance that when I did look in your history on Google that I found something on Steve Jobs?
I don't think so. I just went on nu.nl and viewed an article about Apple.
Okay, about Apple. Is there somebody you talk with about Steve Jobs today?
I guess not.
Okay.
Did I, Patrick?
Because I make the prediction.
Okay.
Can you leave? What is your... Can you see what's standing here?
Yes, it is Steve Jobs.
Can we go closer? That's maybe too difficult, but it's standing there. Steve Jobs. He's a computer designer. Thank you.
Thank you.
Thank you. Are there any questions? No questions? Okay, then we can go on. Ladies and gentlemen, we are ready, more than ready, for our first speaker. And he is the founder and CEO of this great company, and he will guide you on a journey. It's all about the future of programming. May I have your big round of applause for Hans Bossenbroek.
Thank you. Niels reminds me of a quote from Bruce Tocnazini, one of the people who was rather instrumental in designing the Mac OS, who actually says, if you read a book about magic, sometimes you have to go back to the cover to see whether it's not a book on software. So the core of the talk is actually that we think we know about software and software engineering, and it's my contention that we don't. We haven't even touched upon only the surface of software engineering and the impact on society and business. What I would like to talk about is, what does it mean to be a software engineer? If you've ever been in climbing or mountaineering, you know that all these difficult things in climbing have to do with teamwork. And I think if you talk about software engineering, it's about teamwork. Yes. So why is software eating the world? I think most of the people didn't get it right. Because everyone thought in 2011, when Mark Andreessen wrote this, was that we all know the internet. It was about e-business, it was about search, it was about web shops. And actually what Mark Andreessen said is, it only just started. And software is eating the world actually means that it's actually changing the world. So software that's eating the world that means that you don't build your own platforms anymore. You use the platforms. So if you, for instance, look at Uber or Airbnb and other big startups, the thing they decided early on was actually that software changed their strategy. And their strategy was not to build their own platform. Their strategy was actually to use the existing platforms and build on top of that. So the majority of the companies I speak to actually in their strategy have something like, we build the best platform and then some statement. Whereas software eating the world means that given software, you become a different business. You become a different company. For instance, a lot of manufacturing companies that are struggling with IoT or the emergence and the impact of internet all lead to the same conclusion. You have to become a data company. And what does it mean to become a data company? A data company is radically different from being a manufacturing company. So my contention is that because software is eating the world, that all companies will become software companies. And to be a software company means that you have to have a software strategy. And if I look at software engineering and programmers, I just see that they're not part of the strategy process. So if I say software is eating the world, the thing Mark Andreessen said in 2011, 7 years ago, is actually he predicted this future. So the question we have is, what role do we play? So if I talk about the future of software engineering, I'm not talking about the best next technology. I'm talking about some fundamental laws that have been out there since the late 60s and early 70s. I'm talking about a different way of looking at your own field of expertise, the role you have in society and companies. So there are a lot of predictions out there. Do yourself a favor and Google for the future of software engineering. And you get all kinds of very interesting observations. One of the things that makes me cry is actually, this notion is actually a Japanese guy that said, just suppose everyone would be a software engineer. What would the world look like? And obviously the big fear, would there be work for us? Now the sad thing is actually that underneath this question is this notion that everyone could be a software engineer. which is just about how we look at our own profession, which is, let's not make ourselves too important, and let's stick together. So these types of glimpses into the future are way off from what Mark Andreessen said early on, and the role we have to play in society and in business. Last November, I was at the reInvent of Amazon, and this is a theme Sam Aaron will get back to later. And the CEO of Amazon made this link between making music and creating software. I don't know whether I agree with that, because making music is a far more creative process, although maybe Sam has a different opinion on that later on. But it's definitely something of art in software engineering. And interestingly enough, if you look at the way we teach people about software engineering, on average we are on the hard math side and on the not-so-scientific side of things, but trying to learn language to people. Another thing actually that was said is, if you look at the new architectures, they'll be radically different. So, irrespective of what you think of software as eating the world, one of the most important things to understand is that we're getting into a big new time frame with different technologies, different models, and different strategies. And essentially, each architecture that we apply will be collaborative. And not only that, it will be designed in a collaborative fashion. So getting back to the point of building your own platform, this is not about building your own platform anymore. I dare say that anyone who wants to build their own platform is not doing the right thing. Another thing is obviously security. Werner Vogel put it very, I couldn't resist myself in using this quote. It is all about security. And if you look at the way we think about security, and this is not about the hype and discussion about Facebook. It's actually, how do you create an application that's secure by design, way beyond encrypted? And security by design is something only a few people have mastered. Another prediction is human-centric. Just this morning I read that finally Alexa is going to the Dutch market. So Alexa's introduced here, and the big shops are all thinking about voice-controlled ordering. Whereas what I think is far more interesting is, how do you design dialogues that are only voice-controlled? Just last week I was in a discussion about actually dialogues. But on average, we don't think a lot about the actual human dialogue or the human conversation, let alone a human conversation with a machine. So human-centric computing will also be different. And thinking about the interaction with people, not gesture-based or touch-based or keyboard-based, but voice-based, will lead to a different type of applications. By the way, I really like the way Alexa was put in the market by Amazon on the CES 3 years ago, because they really pushed the personal assistant very hard. And the next 2 years, they weren't there anymore. But everyone wanted to integrate with Alexa. So there's definitely something like a first-mover advantage to this type of technology. But getting to grips with the impact of technology like this is a whole different ballgame. And then there's this obvious hypnosis of all code you'll write will be business logic. Here's where they actually go into the marketing terms. So on average, if you look at the big technology vendors, they all have this notion that you only will build, I don't know what it is, but business logic. Whereas what you see is the software we're building on is becoming more and more complex, has more and more, let's say, infrastructure as code. So you have to have a deeper understanding of what's underneath. So I do not agree with this statement that you actually, every program will only build business logic. I think each and everyone will be confronted with a future where you have a much deeper knowledge, need deeper knowledge of the underlying infrastructure. So if I were to combine these statements in one slide, obviously there's a cloud for everyone. And not just the cloud, but a cloud. It's my contention that over the next couple of years, different clouds will emerge. For instance, the IoT cloud from General Electric. It's fully geared towards large-scale industrial installations that want to harness the power of the Internet of Things. So it's somewhat strange to talk about the cloud, but there will be a cloud. And if you talk about cloud architectures, they are different. So in terms of infrastructure as code and the knowledge of the architecture you're using, there's a relatively different approach to programming. So you talk about federated architectures, not isolated architectures anymore. It's not a question of whether your system's networked. The systems will actually be federated. So it can't work in an isolated fashion anymore. It will not work. The database isn't the integration point anymore. We talk about APIs. Stateless protocols, for instance, concurrent processing. The majority of systems actually built nowadays are designed around this notion of sequential processing. Maybe in a couple of streams or processes, but it's all sequential, where the world of eventual consistency and clustered nodes means actually we're going to concurrent programming models, which are radically different from classical programming. And the last part about anti-fragile and resilience, we also have to think about the software systems that are so complex that you can't test them anymore. You can't just switch them off. Last year in the summer there was a huge problem in London on the airport. Actually, I was caught there on London City Airport because one of the people unplugged the computer. Now the interesting thing is, when he unplugged the computer, he didn't know what he unplugged, just he pulled the plug, literally. And it was actually the system where all planes that were going to land had to ask for permission and register for permission. So no plane could land anymore. Now the interesting thing is, it took 6 hours to solve the problem. So thinking about the reliability of complex installations is changing. And we're talking about, as a new term, anti-fragile. But chaos engineering will become part of our daily job. So it's my contention that we need to step back a bit if we understand this. Because if you look, for instance, at the definition of a layer, and you Google, you come with these strange discussions about the difference between layers and tiers. And actually people try to explain to each other why a layer and a tier is different. And it's highly opinionated and subjective. Whereas if we want to achieve something else and achieve a new level that's to be expected of us, there needs to be a common definition of language, of the architecture we use. And it's way beyond Stack Overflow. But it irritates me that actually we find software engineering rigor not as important. Strongly, even a couple of weeks ago, I was at a customer site, and one of the managers told me, yeah, it's all about soft skills. Oh, yes and no. I mean, the worst thing that you can have are actually bad software engineers that want to hug you, or are great at presentations. Software engineering is a very, very difficult field of expertise. So software engineering rigor would be high on my list in the future of programming. And if you talk about the cloud, on average, everyone talks about the technology. Whereas if you really look at why did the cloud emerge and how did it emerge, take for instance EC2 and Amazon. I mean, total revenue third quarter last year was $4.6 billion, with an operating income of 1.6 billion. So it's fair to say it's a rather successful technology company, right? But actually, if you look at why did it emerge, is that in the early 2000s, the IT department couldn't keep up with the way the web shop was hosted. And they redesigned the organization to make everything into smaller teams. So everyone started to deploy their own software, and they made the team end-to-end responsible for the entire design, development, and operation. So it was an organizational change. Next came Chris Pinkham, who was, by the way, deemed to be a perfect manager. And he said, wait a minute, if we take this common infrastructure, we could make a business around this. And the moment he said it, everyone looked at him and said, what are you talking nuts here? You don't sell this. This is the biggest secret we have. So he went back to South Africa, and with his plans actually got to Jeff Bezos, who said, there's a business in this. Get Pinkham back. Pinkham got back. Long story short, actually, he built a common deployment infrastructure, coined the term DevOps, and that's the reason why EC2 was started. So there's actually no one in the history of EC2 that started with a great technical idea. It was an organizational problem they solved. Is this new? No, this is not new, because this is actually Conway's law. Conway stated in the late 60s that there's a very strong relation with the way you communicate and the organizational structure and the software you can build. But if you see what we do with DevOps, for instance, as a religion, or cloud computing, if you take it out of the organizational context and plot it in an organization and say, okay, now it'll work. So fundamentally, this is an organizational pattern which drives an IT innovation instead of the other way around. Conway, late 60s. And what did I do? I mean, if you look at the changing technology landscape, how do we do as a software engineering community? Well, the one thing I always do is frequently look at the Chaos report as it is published by the Standish Group. And I took the 2014 results. 2016 I couldn't get my hand on, and it's rather depressing, because if you look at it, over the last 2 decades, things really need to improve. So just under 30% of the projects succeeded, actually. So even with all the new insights, and all the new technology, and all the new business models, and the way we look at our field of expertise, on the left-hand side, we're struggling on what's the definition of a layer, and on the right-hand side, under a third of the projects succeed. Stronger even, if you look at what drives success, it's actually user involvement and executive support. Although I don't believe in the clear requirements, but that's their story. And very consistently, it's about people. That's an interesting one, which feeds into this notion there's a shortage of programs coming up. So it's about people, it's about experts, which feeds back into the software rigor story. Because on the other hand, and here's where the 2 pizza as a team story of Amazon gets back into, it's about small projects. Mega projects on average fail. And we still, on a day-to-day basis, start mega projects. Stronger even, lots of companies build their own platform in the assumption that you can actually build a new platform, which I don't believe is true. So smaller is better. People are the primary drivers, and agile projects are more likely to succeed. Although, if you read Uncle Bob and what he said about the future of agile, there are some questions there to be posed as well. But it's interesting. It's interesting to see that these are the most important characteristics of successful projects. And what does it leave? Well, a huge shortage in programmers. Which brings me, this is a developer for developer conference. And Bert asked me, Bert's there, in terms of how do you recognize a recruiter? Well, on average, with a suit and a tie. So everyone who's here who's wearing a suit and a tie will probably be a recruiter. We tried our best to sort of keep them out the door, but if we didn't succeed, well, very easy to recognize. Another question, could everyone stand up? Come on. Cool. Because if you talk about software engineers, everyone needs programmers. So just a short skill test. Will all the men sit down? Fuck me. Thank you. I mean, this is the whole point. Sit down. This is the whole point. Also this morning, what was in the newspapers? We had a huge improvement of female uptake in secondary education in STEM subjects. We went for, I think, to just over 20% for girls. Boys actually far over 50%. And we're happy with 20%. And mind you, if you look at the future of the careers of women, on average they stop before they actually get into this field. So we have a huge need for programmers, but we have created this thing which is highly masculine. We did our best to find... Einde? almost. Because if you talk about education, and look what's on the huge polls on Stack Overflow, you see that it's not about formal education. Stronger even, if you look at how people are educated, it's interesting to see that 1 in 10 only finished secondary school. 1 in 10. And professional developers, a bit better, but still. So we have this disconnection between how we train people in software and the way we do our work. Stronger even, the majority of software engineers is self-taught. I dare to say that we don't know how to train people in software engineering, which feeds back into the software rigor discussion. We just lose track of it. Even programmers. Which brings me to the core of the story, the Dunning-Kruger effect. In the late 90s, two psychologists did a research into the confidence of professionals. And they said, if you take the confidence of a professional and plot it against the level of experience, you get this strange model. This is the way. This is what we refer to as the peak of Mount Stupid. It has a similarity with the Gartner hype cycle, but that's not actually what it's about. And you know what? This is where software solutions are usually sold. So if you talk to the big vendors, usually you get something that keeps you either on the left-hand side of the peak Mount Stupid, so that you always climb peak Mount Stupid, or wants to keep you up Mount Stupid. Whereas if you look at the other end, what's on the other end? What's at the expert side? When you talk about Frederick Bruce, there are no silver bullets. Conway's law about organizations. Dijkstra, layers of modularity, 1970. Parnasse, 1972, the definition of interfaces. So the deeper knowledge about our field is way out there. It's just that we often forget it. So to close my 2 cents, let's be aware of what it means to be on peak of Mount Stupid. Because it's out there, it is. Second is, it's impossible to ignore cloud computing. I think software engineering rigor is key. So we need to understand it's a serious business we're in. We have to rethink how we learn how to program. And software is not only eating the world, it's also creating a world. Which actually means that I think, this should work, yeah. Every strategy is actually a software strategy. And every time I say this in boardrooms, you get the reaction, nah, that's not completely true. You want to benefit from software. And the point is, you can't. So every strategy should be a software strategy. And I think in the next couple of things, we'll talk about how we're going to learn children how to program. We're going to talk about new markets, and we're going to talk about the peak of Mount Stupid. So with that, I'd like to sort of put context around why we're here, which actually is to take your business not only personal, but on a professional level. Thank you.
Thank you, Hans. Are you available if there are any questions later this day? Thank you, sir. Give him a big round of applause. CEO of Luminis. Yeah, a few weeks ago, I sent Hans an email. Hans, what I shall wear? Hashtag dress code. And he sent me a mail back. Please do not wear a tie. Hashtag then they think you are a recruiter. I told you at the start of this convention that I'm an illusionist, but I also think you are a group of magicians because you're creating magic every day. So it sounds for me like a good idea to collaborate and work together in a magical experiment. Is that okay for you? Hey. I have a balloon over here. Like this. Because one of the takeaways of Hans' story was the great role children play in the future of your profession. So maybe we can do, if we are a group of children, and play with a balloon. Throw it to each other till I say stop. Stop. The next person, please take it. 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 Yes. Sir, can you imagine in a few years the DevCon convention is not in Ede, but some place somewhere in the world, in another country? And you will tell us now, and please be aware that I tried to find my way in your mind in the last hours from the start of this day. So challenge me. Where is the convention in a couple of years? Bonaire. It's a great idea. We go to Bonaire, Hans. Okay, can you throw it a little bit further? And please catch it. It's important also for the time. Thank you. Hello, we are in Bonaire. And we checked in the hotel, and then we go to the restaurant, and we eat a lot. But there is one dish on the menu you like the most. What did we eat, or what are we going to eat in Bonaire? Swedish meatballs and mashed potatoes. That's a great dish. Throw it a little bit further. Yes, we are in that restaurant eating meatballs. And when you are eating meatballs and chat with the people around you, you hear something from the speakers, a special voice. You didn't hear it for a long time. Who is singing a song for you? Bono. It's going to be a special night. Meatballs and Bono. Last time. And please, to one of the ladies around you, catch it again, and give it to one of the ladies. A little bit, yeah, oh. Yeah. Hello? What's your name? Ilonka. We are in a restaurant in Bonaire. We're eating meatballs and listening to Bono. And very kind of you, you will pay the bill. Because Hans is not there at the end of the evening. So you have to do it. What is the total amount at the check? What do you need to pay? 15,000 euros. Okay. Ilonka, did you ever go to Bonaire? It's a lot of money here for Bonaire. Would you like to visit me on stage? Please do. You get a round of applause. On this side, Ilonka. Oh, be careful. Yes. Ilonka, I have something dangerous in my hand. Ilonka, where you come from?
Ede.
Ede. Okay. Ilonka, please stand here. Can you first check that this is a real needle?
Yes, it is.
And try to hear, because there is something in the balloon. It's light, but can you hold your left hand the nut of the balloon? Yeah, and with your right hand at the count of 3, please touch. 1, 2, 3. Yeah. I don't take it. And I told you before, I think you're a group of magicians, and maybe you would like to see what magic can do, please focus on the face of Ilonka. Ilonka, can you open the white paper and first announce what's written on top?
Bonaire, sweet meatballs, Bono, and 15,000.
Yeah, it's really small, guys, but I hope to see you in a few years on Bonaire.
I hope so.
Thank you. Yeah, the important role children play in the future of your profession. Somebody who knows everything about this and especially how to do this in the right way is our next speaker. He's a researcher, he's a software architect, he's a computational thinker with a great interest for the surrounding the notion of communicative programming, and is here to tell you everything about this. Please give him a big round of applause. This is Sam Aaron.
Hello there, how's it going? Can you hear me? Right, I've got no idea what I'm going to talk about. I haven't actually prepared any slides. Is that okay? Because slides, who wants slides anyway? We have code, and actually we have the previous person's, Hans's stuff there, so we can exit this. So, my background, this story I'm going to tell you here for the next sort of 10 or so minutes starts here in a classroom. Now, a few years ago, the UK, I'm from England, did an amazing thing, the government, and they introduced computer science into the curriculum, like properly in the curriculum, not just how to use Office and, like what are spreadsheets, although actually they're very useful things, but also programming, teaching kids how to code. And I still am at the University of Cambridge in the computer laboratory. And at the time that this was happening, another fabulous thing happened, and that was out of the labs spawned this really, really small, really, really cheap, but yet quite powerful for the price that it was, computer called the Raspberry Pi. And that came out of the computer labs, and it was a miraculous success. They thought they were going to make a few thousand. They've sold maybe it's like 15 million of them, something now, some crazy amounts. But in the early days, in the first sort of 7 months, they were just flying out the shelves, and all these kids and people were buying them. But there wasn't really any software that could be used to engage kids. And so this was the question, could we actually write some exciting software that was going to run on the Raspberry Pi that we could get kids programming with? And this is the lesson, this is the classroom I actually worked in. So that's the teacher there is Carrie Ann Philbin, and this is her class of kids learning how to program. And it was, have you been in a classroom recently, any of you? A few of you. I don't know what the Dutch classes are like. I imagine they're fairly similar. Like a period, maybe it's like half an hour to an hour, and in that time, the teacher has essentially no time. It's all getting the kids in the classroom, getting them sitting down, getting them quiet, before you can even impart some knowledge. Right? And once you've like, Timmy, stop spinning on your chairs. John, get off the table. Like once you've done all that, and then you've maybe gone like, I'm going to say something, everybody. 5, 4. It's like sometimes they really need some training to get them focused. 3, 2, 1. What is the statement you're going to say that's going to teach them programming? What's the statement you're going to say that's going to get them excited and engaged and interested? And in the UK, once we had this new curriculum came out, all these sort of big bodies who are working in education, they came up with fabulously engaging titles that are going to just get the children salivating with excitement and enthusiasm for programming. They were, ready for this. Give binary a try. As if it's like maybe that's some sort of like it's a gateway drug to programming, binary. Once you've started on noughts and ones, that's it, you're never going to go back. Maybe for weirdos like me, and maybe some of you, that might have been a great start. But if we're trying to engage a broader, more diverse audience, perhaps it's not the best. The other one was, and it had a good start, have fun. Right, that's good, right, good, yeah, have fun. With sorting. How many of you ever had fun sorting anything in your lives? Right, none of you, good, because I don't want to spend time with you at all. To me, this was a problem. And so I think that we have a few questions to ask, and I have a lot of things to say, and so if I run out of time, come and find me later, and I'm very happy to talk about them. But one of the main issues is this, how do we engage people? But also, why on earth do we teach people programming? Why should we bother? We heard earlier, there is a real shortage of programmers, and it really would be lovely if we could have more people, especially more diverse range of people programming for industry. That's who I'm talking to right now. But actually, I think there's a bigger, broader aim. In the same way that I can imagine in a few hundred years ago, I'd be working on the farm, plowing the field, digging. My father and my mother were doing the same, and their father and mother did the same. And so for generations, we've been doing the same work on the farm, and it's been fine. And then some people from the city come and say, right, you need to learn to read and write. Like, why do I need to do that? I just do the farm. That's all I need. No, it's really important. It's going to change the world. And obviously at that point, people who were reading and writing would have been people in law, perhaps, doing legal contracts, or people in education at very, very high up at university levels, or maybe religious people writing their tomes of religious works were reading and writing, but certainly not the farmers. Now, can you imagine if, let's try and combine these worlds. At those points, the people who read and wrote they did a very small subset of the things that we write and read today, clearly. And imagine a world where that was only the case. Mostly the writing was for legal documents. Imagine that. Imagine if Dutch was only ever used to write legal documents. Why are we using programming only for business contexts? It's a similar kind of problem. Clearly it's important. We need writing and reading for legal documents. We also need programming for business contexts. But we can read and write poems and letters and to-do lists. So go to Albert Heijn. I want to buy some paper nota. So you want to be able to express yourself with writing. And I think actually there's the same true with programming. And I think the way to engage children is not just to say, and it's a really valuable point, learn to programming and there's an industry awaiting you. In the same way you don't say, you need to learn sports to become a professional sports person. You learn sports because it's a fabulous thing for your body, your mind, for teamwork. I think that's the same with programming. What is the equivalent of sports or programming, where you're not necessarily training people to be professional sports people or professional programmers, but you're using programming to broaden their horizons and allow them to engage in the world in deeper ways. And to me, that's the exciting thing. And so, and what I'm saying is none of this is new at all, right? Let's have a look at some of the pictures. So this is Ada Lovelace. Hundreds of years ago, she was with Babbage designing the analytic engine. And there were obviously cogs and wheels and mechanisms and pulleys. But she said, when she was looking at these things, this engine, which is actually just a computer, might compose elaborate and scientific pieces of music of any degree of complexity or extent. So this was an imagination of one of the world's first programmer. And she said that actually we can use this stuff for art and for expression. And this interface I'm showing you here right now is my attempt to try and get some distance towards this idea, which I use for my own scientific pieces of music, but also I use it to teach people how to code and teach people how to engage with programming in general. And so where do I use this programming environment? Well, this is me performing, well, maybe I'm writing emails, it's not, who knows. Because when you see computer musicians making music, you've got no idea what they're doing, really, do you? So they've got a computer on stage, but what is the computer doing? It's a cool stage. So I could be writing emails, but luckily, the festival there, they projected my screen on the big screen. So this is just in the same way I'm projecting my screen here, they're doing the same. And this is code that I'm writing to make the music. And this is, I think, is an exciting new way to express yourself. It's not the only way to use programming. Obviously, you use programming for many other things, like having fun with sorting. And I'm sure you've all given binary a try. But yes, and this is how I might start a lesson and say, look, you could do this, right? Not sorting algorithms, but actually performing on stage. Like, whoa, how do I do that? So then you have to get them in started and get them in going. And what I'm showing you isn't just for the England's classroom. So here is a whole Twitter feed from Code Bus Africa. So Finland sent a bus to Africa and taught 2,000 children, primarily females, how to code with my crazy music system I'm about to show you. So this really does cross cultural barriers. I'm trying to show some pictures of classrooms where people are coding music with headphones. It's beautiful, so check out this feed. So it really is, it broadens it, not just in the UK. So let's just have a look at what you can do with this. So this is a system, it's called Sonic Pi. It was designed, as I said before, for the Raspberry Pi computer. So if you buy one of those, the software is installed by default. But it also runs on a Mac and a PC. It's an entirely free system, so I'm not trying to sell you anything. I'm just saying you can go home tonight and download this. And actually, if you get your children to download it, or your friends who aren't programmers to download it, because how many of you have been to parties? Not many of you. Right, okay. Okay, that you need to, first of all, get invited to a party. That's step one. Step two, have a conversation with somebody. Because, I mean, once you got into the party, that's not enough, because you get into the party and someone says hi, you say hi, they say, what's your name? And I say, Sam. And they say, what do you do? I'm a programmer. And they walk away, don't they? And I don't say that anymore, I lie. I say I'm a musician. Oh, cool. What do you play? I play code. And now I've got them, right? So the conversation. So you want to find ways to try and broaden this conversation. We need to be speaking about programming to not just programmers, but non-programmers, and getting them excited and understanding what they can do. So this is a tool you can use to have that conversation. And of course, to do anything in this system, you've got to write some code. This is the first program you would write. So in a classroom where the children are spinning on the table and you've got them quiet, this is your first sentence you will say to get them started programming. And that's just write the word play, because it's to have fun, but we're not going to sort anything, we're just going to make a beep. How can we hear that? That's as loud as I go. There we are. So that's a simple program. And of course, we can obviously introduce bugs, we can spell things incorrectly, we can get errors, and then we can talk about the fact that programmers spend most of their time in an error state. That's the normal position, because once you've solved the problem, you're on to the next one. But people don't realize this kind of stuff that's blatantly obvious to us. They think that programmers always produce the correct code. No. So getting them to have bugs is really easy. We talk about abstractions. What do numbers do? Somebody might know what numbers do. They go up and down. They can count things. It's useful. Do you not do numbers in Netherlands? 1, 2, 3, 4, 5, nee? So the cool thing about numbers, because I can't believe you don't know that. I'm just going to pretend you do, and you're just humoring me. The cool thing about numbers is they go up and they go down, and other things in the world can go up and down. So we can use numbers to model those things. So like I can jump high, go low, or I can speak really high, or speak really low, or I can play high notes and low notes. Now this is fun, actually. The last time I did this was actually in here, because it's got an amazing bass system. Let's make it. Oh, yeah. Yeah, right, so that's a lot of fun, right? So just with one number, you can play around, change the amplitude. I've got parameters here just to introduce the things. But then I can play 3 notes or 2 notes. Notice these actually happen at the same time. So with my system, Sonic Pi, time is really an important thing. And if you don't mention time, everything's simultaneous. And so both these plays happen at the same time. If you want to make a melody, you need the sleep command, and then there we are. Or that's a quiet one, so I'll make it a bit higher octave. Add 12 to it. There we are. Or let's go for a different one. Synth profit. This is a nice one. Release time 8. Cutoff 70. Amplitude 5. 4. Note E1. Wow, we're in the cinema now. Right, so you can really have, with one line of code, you can have a huge amount of fun. I've only got 4 minutes left. I can write 4 lines, perhaps. But so you can start to see how you can get them engaged straight away with making some music. It's a lot of fun. But of course, when I performed on that stage, I didn't do that one line. I did many, many different lines. And where can you go with this? Well, I have 4 minutes. Let's see what we can do. So what we can do is we can have loops. Let's sample bass drum house. Sleep for half a beat. We get a kick drum going. Right, that's good. Maybe we want, instead of the kick drum, or in addition to the kick drum, maybe we want a different sample, like this bass thing, like this. Right, so, and this, within 4 hours, the kids are doing this, right? And so maybe they want to have that and the bass drum house going at the same time. Let's sleep this for 1 second. Right, so we're going to play the kick drum and the bass at the same time. No. Can anyone see why we can't hear the bass drum? This is a fundamental computer science question here. Yeah. Sequential programming. We talked about it before earlier, Hans said. So the code gets to the first loop and stays there forever. Never gets down to the second loop. Now, I found this fascinating because in the UK curriculum, the loops are a fundamental part, iteration, conditionals, this kind of stuff. So this is that tick for the teacher. Yep, we've taught loops. But solving this question, which all children ask very quickly, how do I play the drums at the same time as the bass? The answer is you've got to wait till university because it's not on the curriculum. We can't do this. We can't actually interleave these two things. And the kid's like, what? That's rubbish. And then the teacher says, sorry, it's not on the curriculum. I can't spend a second of my time on anything that's not on the curriculum, which makes me want to pull my hair out. So this is where, as programmers, I find this beautiful. Like, we don't have to stop here. Right? We don't have to go, okay, you can't do it, got to wait to university. You can cheat. And this is the cool thing. The weird thing about education, it teaches children not to cheat. You can't cheat in your exams. But in the workplace, if you don't cheat, then you're not going to make it successfully. You have to go and ask people the answers to questions. Like, you don't need to know all the answers yourself. You have to create new rules. You have to break the bonds and experiment out of the normal places. And so I created a new kind of loop, the live loop. These live loops, you need to give them names. So this is Fred, and this is Kate. And, I've got an error because I removed the O of the do. And now they're playing at the same time, right? So concurrency for free. So these are threads executing at the same time, concurrent programming. But the teachers don't need to know that. But the cool thing about this is that I can actually start modifying this. And maybe instead of that, I can see for a short amount of time and play synth beat, note E1, have a release time which is short, and then maybe that's too low, so let's experiment mode, making it higher. And maybe make a scale E3 minor pentatonic and choose one of those. Reverb. And then maybe add our friends, the prophets. Release 8, cut off 70. You've got to spell correctly, otherwise it won't work. Note E1. And we're making music, right? And I haven't got time to really go nuts, and I will later, so you come and find me to go nuts. But what I'm showing you I think is the important aspect of this, is everything I'm showing you, every concept, I can teach to a 10-year-old child. Right? This is a crucial thing. And so, when you're designing systems, new systems, try to think about making them simple. When I started this system, I made it simple for the classroom, and because that was a requirement. But it turned out that a system which is simple enough for the classroom is so much more fun to play with as a user, as a musician myself, but just great to actually then use as a tool to converse and to communicate with people. So now, I have a friend in Belgium who's written his own album in Sonic Pi. And I can phone him up or Skype him, and we can have a conversation about music production, and we're using terminology from Sonic Pi to aid that communication, mainly because it's simple and not complicated. You're not having to understand the full technical stack to make a concept which is related to the music production. And so I think this kind of idea of making things simple in all of your work actually has profoundly important benefits, in addition to making it more accessible for newcomers. But anyway, I think I've run out of time. So all I'm trying to say is that programming is hugely creative. We need to find ways of engaging everybody, not just children in programming, and that means breaking out of the business mold. What can we do with programming that's not just business, like what can we do with language, which is not just legal documents? And find ways to celebrate our creativity. We are, as we mentioned multiple times already, we really are magicians. And we really do have amazing powers, and we really should be trying our best to think about what are the ethical implications of our work. How can we do work which is good, that affects people positively, and really think deeply about that. I think we're at a crisis in our industry where these things haven't been considered as much as they should, and for going forwards, we really should think deeply about this. And I think, how can we have a party as programmers? Thank you very much.
It's absolutely surreal. You only see this place on pictures, and now you're standing in the middle of it. We've been tested on so many things that are outside of the box that a normal sim race would think of.
Rudy Van Buren has crashed out of what should be first position. That's a huge moment.
Here we have some world fastest gamers.
They're all unbelievable gamers. Being fast isn't just enough.
It's the first chance for us to see the finalists here in the MAT simulator.
This was the most amazing experience in my life. Just sitting strapped in that Formula 1 cockpit. I'm not able to put it in words, it's amazing.
24 hours of Le Mans is the ultimate test of endurance.
3 of us and doing 8 hours each probably. I think the whole atmosphere will make it fun.
It's a really hard choice we need to do now.
And it's Rudy and Freak who'll be tested in the actual Formula 1 simulator.
There was some pressure on that one. That was the most difficult thing I've done in a long time.
These are the top gamers in the world.
They're up against one another, and we're looking at seeing who's going to be the ultimate winner at the end of the day.
It's been absolutely mind-blowing. This is a once-in-a-lifetime experience.
Ladies and gentlemen, please give him a big round of applause. World's fastest gamer and now the official simulator driver for the Formula 1 McLaren racing team, Rudy Van Buren.
Thank you.
Rudy.
Good morning.
Good to see you. Let's stand over here for a moment. Rudy, that was an amazing video.
Yeah.
Where was this?
This was in England, Woking, at the factory for McLaren.
Yeah, and you closed the video with the line, this was once in a lifetime, but that isn't true.
Well, once in a lifetime in a way of that, it changed my life. This was the video of the finals week in Woking, which was like the highlight of the whole competition of who's the fastest eSport gamer, who's going to be the Formula 1 simulator driver for McLaren. And this was a life-changing experience.
How did you manage to beat 30,000 competitors?
By doing the things you know you're good at your best, and make sure you're at least average in everything you know prior to going into it, that you're not going to be the best at it. And this might sound a bit dubious, but if you go into things, you know where you're good at. We came there, we had different games we were going to run, for example. I knew 3 games where I was good at, and then you got 2 games where you know there are quicker guys here. So the only thing I could do at those points was like be good in the 3 and make sure I'm better than the other guys who are not familiar with the other games as well. So stay close to yourself, stay calm, and just make sure you're on your aim game as far as possible.
What do you think the next time this competition is there? It's live. Now we're 30,000 competitors.
Mm-hmm. Yeah, I think it will go up quite a lot. When World's Fastest Gamer got announced, people were skeptic, and I was one of them, because we've seen more of these campaigns within sim racing, and most of the times like, well, first we see, and then we enter next time. But me winning this one, and McLaren actually stepping up to the game and using their whole brand to show World's Fastest Gamer what it's actually about, I think it's going to go 2, 3, 4 times as much people will sign up for this year, because I've done so many amazing things already, from being at the car launch, to being at the winter test, going to races, being a very good amount of days in a Formula 1 sim. It's such a total package that people are in some regard jealous to it, which is good, because that gets more people into the new World's Fastest Gamer competition.
What is the importance for McLaren to have a simulator driver in their team now?
Well, McLaren has the F1 simulator, which is purely about car development, not just driver development. But currently in Formula 1, they've got 8 winter test days. And those days are always a bit mixed, maybe, with some problems left and right. So it's 8 days is very minimal for such a huge company and a huge facility doing the races. So they make a simulator model which is super accurate, so they can test every little thing that gets put on the car in the simulator. So that's where the software part comes in as well. So if they, for example, to keep it simple, update something on the front wing, they test it in the simulator first. If it's good in the simulator, it's going to see the real track. If it doesn't work in the simulator, it's never going to hit to the real track. So they need drivers in the simulator who can be on their A game and be on point every time when they're in the simulator. And because McLaren is looking into new directions, defining the tiny bits, they also looked into the direction of getting an eSport gamer. In this case, it's me. Next year, maybe someone else or whatever. To find a different look on certain things in the simulator, different feelings, different approaches, just to get that little bit extra compared to the other teams.
Can you tell us a little bit more about how your typical day looks like when you're in London?
Yeah, well, if you can see, like, if you take the month, like 1.5 to 2 weeks a month, I'm in England. The other way, I'm just stationary at home. I've got 4 big tasks. We've got 2 simulators, we've got the fitness part, and we've got media events like this. So we cover them all. And that fills it up nicely. I've got weeks where it's just purely fitness related for me at home. Train twice a day, got the fitness program. They try to get me up to an F1 level, because don't get me wrong, the simulators of the Formula One are physical to drive. It's mostly underestimated. You take a desk and you put the wheel on and you drive. And yes, that's how you start at home. But if you get to a Formula One simulator, yes, there are G-forces and so on. So that's one of the things that's a main priority when I'm not in England. And apart from that, it's visiting races, doing events like this, and just doing what I love, basically. They've said it before in many quotes, that it's like, for a racing guy, it's like the lifetime dream to have this job, and it is. And of course, for someone who's not racing related, they think it's not for me. But of course, from my own point of view, I've got the best job I can hope for.
I can imagine. How do you look to the future?
Well, it's all open for grabs, because I'm the first one as world's fastest gamer, so not everything's set in stone. It's partly up to me, it's partly up to them what the program will look like the whole year. So my contract runs out at the end of the year, because that was the whole prize of the competition. You get a 1-year contract with McLaren, and it's up to me to make sure that they don't want to replace me or don't need another person next to me, make sure I'll be there next year.
First of all, give him an applause. Rudy van Buren. Rudy. A guy like you, it's a hero's journey. You're playing the most sexy game in the world. I have another game with me.
Oh, God.
It's an old-fashioned game. Maybe we can play the game. Can you try to do it behind your back?
Yeah, of course.
That's more easy. And try in, let's say, 10 seconds to do your thing. Try to fix it. Can you count from 10 to 0?
It's McLaren orange.
It's okay. Let's see if it's behind your back. One part is similar like mine. That's maybe good to check.
Yeah.
3, 4, 5, 6. Thank you.
Thank you.
Rudy. That's real magic. Ladies and gentlemen, we are almost at the end of this first part of the day, but we learned something about the future of programming. We learned something about the importance children play in the future of your profession. We learned something about the eSports and the impact of programming of Formula One. But now I'm really curious what we can do to change the world when we chat together, when we share our knowledge. So, Hans, if it's okay for you, would you like to come on stage one more time? Can you solve it?
No, not now.
Ladies and gentlemen, one more time, please. Your applause for Hans.
Okay. By the way, Rudy will be on the R-Factor stand here today, so to give you all racing tips. So if you want to talk to a pro, someone who actually knows how it's done, go there. I'll not be there because I'm totally useless at the thing, but I love people doing it. So go do yourself a favor and talk to Rudy on the R-Factor stand. So we talked about my 2 cents on the future of software engineering. We talked about educating people and how you learn and program. And I think the main takeaway on the R-Factor and the sim racing thing is, by the way, it's not a game, it's actually something completely different, is that it creates new markets. So software is eating the world, but it's also creating new worlds. And to give you an idea, 2 years ago there was a huge sim racing event in Las Vegas with the main prize of $1 million. So it's $1 million just to play games. Now it's actually $1 million in a very competitive environment. So the main takeaway of the keynotes were different way of learning to program, new markets, and the third topic, and I think I'm very short in time, is the most difficult one, which is actually, how does it feel to be on Mount Stupid? And I've been on Mount Stupid a couple of times, and I'm not scared to admit it. And I'd like to call on stage René van Hees. He's the Chief Architect of Thales Naval Netherlands. And I've been on peak Mount Stupid with him. Right?
Yes. Hey.
Hey. By the way, I've also been on mountains with him, so I know in real life what it is to be in the mountain with him, as well as in software projects.
I'm not sure I'm proud of them here while being on Mount Stupid, but I give it a try. I'm not sure if you can see all this ball here. This ball is, I'm working with Thales, we make the world's best radars, I can state. If this ball would float around this building, we could see it from Hengelo. Hengelo is where I'm coming from, you hear my accent of course. And we would see it. And that's the only thing we see, we saw it already in 1996, so that's 20 years ago. Until that time, we improved our radar systems, and until now we can see our satellites, what about the big as the balloon that's what exploded here, we can see it in low orbit. That means that we are coming up at Scotland and going down behind the horizon in Spain. That means...
And these balls aren't static, right? They move actually.
They move, of course. Yeah, we put them, we put it in a balloon, and we let the balloon up, and it floats by the wind, so we can see it and calibrate the radar. So used for radar calibration. But we can see missile coming up the horizon. So we do that not in static systems. I put this ball here. I put this ball here. We do that. We put our radars on ships, and ships are moving vessels. And if we have a big storm, then it looks like this. There's rain or water besides the radar system, and we still have to track these satellites to give you an impression of the surrounding environment where our products are. And you can imagine this, that we have to stabilize the beams where we transmit. So it's like sitting on a mechanical bull at the, well, I think there's one here, and it's moving around, and you have a torch, and you have to follow a pigeon while moving on this electrical bull, a mechanical bull. So the radars are on ships. The ships are, they have to have a high position to have a clear view. So the ships are fabricated around this radar system. They have a clear position. That means that our radars have a long life cycle. They are maybe 30, 40 years on ship. And the world changed. For example, now at the right bottom, you see one of the radars where it can detect classified drones. And drones are like birds. And about 95% of the detections we do is birds in coastal waters. That means that we have, for all these 95% of detections, we have to check, is it a bird or is it a drone? And the operator does not want to see birds, he wants to see drones.
But that must be very sensitive technology. I mean, you can't just sell it to everyone, right?
No. The technology we have is then, we call it Dutch eyes only.
Yeah.
Only people from Holland can work, even though we're a French company, this is closed proprietary knowledge. and we have only Dutch people, Dutch eyes looking at this
so
stuff.
sometimes you say to me that stealth is actually something that doesn't work anymore, right?
Sorry?
Stealth technology doesn't work.
Yes, because we see the ball, a big advantage of the stealth fighter was that it was invisible for radar. Well, we proved that stealth is not a selling feature anymore.
No.
So drones, for a software architect like me, putting drone technology, drone classification technology in radars that are 10 years old or 20 years old, this has, well, old technology. It's very hard. So you have to put in a lot of processing power in old stuff. And there you see, and at the left bottom, you see old radar being repaired. So we have to do it in maintenance, have a big lifetime upgrade. And the last one is, we all want to have a clear position on the ship. So what we did is to have the integrated mast. It's 3 floors. It was built in Hengelo. It was integrated in Hengelo. And we test communication equipment, radar systems.
How many computers or servers are there in the mast?
They're put on the bottom because the weight is quite high, so the ship is not going sub water.
Yeah.
But I think about one radar, you talk about 100 boards of computing power to put real-time processing on this radar system.
Serious.
It's serious business, yes.
Okay.
And what I said, put this technology in, new technology in old stuff, new algorithm in old stuff, having leading products, leading radars, is a real challenge for radar. And to come back to your keynote, the last thing we need is technology from Mount Stupid.
No, exactly. So talking about this should work. Talking about Mount Stupid.
Yes.
What was our Mount Stupid?
Well, in 2007, we developed our own platform. I would say middleware layer. I don't say platform. I say middleware layer. So it's everybody's hobby in our terms. And we had it quite powerful, layering, generating code, and we put it in XML. So I would say XML is Mount Stupid a bit technology. Yeah. And we find out going to radars with hundreds of boards that did not scale. No. I did not scale for 1 meter, to put it in Dutch. And we had a problem with building big radars, having several XML files being consistent, describing a lot of things. But we generated more than 50% of our code from these models. Yeah. So we need a solution. And that's where you came into picture. We called in a very expensive consultant. And he told us there was a new invention called MDA, model-driven architecture. It's from the book, MDA distilled. It's very nice. You break abstraction with this model-to-model transformation, model-to-code transformation. You have validation of your model. It sounded perfect, so we went into...
Great consultant, by the way.
Yes, it was a good friend of mine. And anyway. So we could model now in UML. So visualize it, model our systems in UML, generate code from it, validate it. Looks nice. 50% of code generation is very good. We had Philip Kruchten, one of the 4+1 guys in Hengelo for an architectural course. And he was very impressed by the amount of code we could generate from models. Yeah,
so you could say literally on the pinnacle of Mount Stupid. Actually, let's say the top end, right?
Yeah, it looks very promising. Yeah. And we're now 10 years further.
Yeah, but that wasn't the solution, right?
Not a solution for the long term. We have our products very long term. So looking back, I could say bluntly that you can one thing model in UML very well, that is UML. The U for universal is our problem. You could say the guys have problems with modeling, putting their problem into the UML stuff. Yeah. We have problems in putting several components into one module. Mapping a module on physical hardware. That's not something UML can do. You have to do kind of tricks. It's very hard, so very few people can remember how to do it, and because you do it on a regular basis. And after those years, you come to imagine that you need to model variation, product variation, because you need to have changes to keep your product alive. You need more dynamic system to model, because maybe code will vanish and reappear. So it's very hard to do this. Well, I would say impossible to do this in a model. UML experts we mentioned, and static products. So it's not the solution for the long term. So we have to change.
Do you consider it a failure, the UML experiment?
No, I would say that it was a success. Clearly a success. We learned a lot from it, but And making errors is human, I would say. So we have to be able to repair it. So we have to get off Mount Stupid. On the right side, going to the wisdom side,
Exactly.
and not going on the left side, because...
So it's not the next new hype, right?
No.
Exactly.
So we need something, a solution.
Yeah.
And as Hans already mentioned in his keynote, the similarities with Back to the Future. So Back to the Future of software architecting is looking back at Mr. Dijkstra, Parnas, Conway's Law.
Actually, when we prepared this talk, René had checked whether he could buy a flux capacitor on eBay, and you can actually. I don't know what it is, but you can buy one.
Yeah.
But going back to the future is a difficult topic, right? Because the underlying, let's say, laws of software engineering are complex. They seem simple.
Yes. So we have to go back and see what are the fundamental things we should use.
Yeah.
And what do we want to solve?
Yeah.
And we need to. What it's saying is that we need to prove a couple of complex things. Evolvability. We want to keep our products alive for a long time. Longevity is the products are there, the technology will get older. What do you do to solve this kind of thing? And resilience, if a board breaks, it's evident in our world that you could have a very critical situation. So you want the system to continue to work. So resilience is important. And by the way, all these things add complexity. It does not reduce complexity. You have all these to solve these things. But we want to have controllability in the means of, we want to know how much money does it take, how much time does it take to develop these things.
How long does it take to build a new radar? You know, how many years?
Well, we are very happy to reduce it from 10 years to now 3 years. So we solved a lot of serious things, but 3 years with 40 to 60 people working on radar systems, it's a long time. It's a big an effort.
Yeah.
So we meet again in 2013. 2013. We have Enetics, and Enetics we said, okay, we cannot do this alone. We have to maybe build a new platform, but go back to the basics, go back to what these old masters, these old Jedis learned us from the past.
Exactly.
And we founded a new project called Enetics. We did it with several partners, and he called it an open collaboration effort because everything we did there is opened and put on the site. But a side note is that for Thales, using open source is one thing, but producing open source and helping forward open source is another thing. So that was also quite a nice thing to do.
Yeah.
And we built on a reference architecture, reference implementation for dynamic service-oriented architecture, and we had the thought that evolution can be designed as a system. And by discussing, we actually act up with you must design it into the system. You cannot put it in afterwards. So if you're thinking about products putting in the market, you cannot say, the things will change in time and I will evaluate it and I'll build it in when it's necessary.
Yeah. So I like your statement actually that you say, I don't just need agile processes, I need agile products.
Yeah,
right?
Yeah. So, of course, we went into Agile and Agile Scrum and Kanban and whatever you have there to have an Agile process to produce your products. And we came to this discussion about resilience and about evolvability. But if you want an evolvable product, Agile software development is not the end. I mean, you need an Agile environment. You need an Agile company. To have everything agile and be able to change hardware or software, whatever, when you need it.
So the reference architecture you mentioned is actually based on these, let's say, principles.
Yes, so these are the principles coming from our discussions and our insights, and we said, okay, at least we have some coordination layer on top of this. So we have layers, yes, we have layers. Okay, I'm not scared to admit it. This is what you need to manage complexity. So you have a coordination strategy on top of this, and you change things. So
you explain the architecture in, let's say, 5 minutes or so.
Okay. The last one I always have the time pressure. So we have to have evolvability and granularity, we have a component service model, which consists of the orange parts are components, the green button, and they are physical. You can program them, they're very hard. You can put them together into modules, runtime or compile time, or development time, build time, and you can describe them in a DSL, in a domain-specific language, which fits to the architecture, which is much more suitable than programming, modeling, drawing in UML. Because you can merge them, you can branch them.
So you have layers, and
Yes.
you have modules, actually formalized. So you
Yeah.
can do current engineering by sort of factoring out different module development to different teams, right?
Yes, exactly.
So it also changes the way you organize software development.
Yes, you can do it. Things
One way applied.
Yes, you can do it in parallel. You have, and all the modules are ending up in repositories. So what do we do in applications? In current days, we model the applications in UML. So we have a large, consistent model. And it has to be consistent, so agile and producing code from the model is hard because you have to validate, etc., etc. So we had some effort there to split up the model. But in this architecture, you reason about applications. So each module has its own meta information to reason about applications, so you can coordinate from a higher level and just pull off executables from the target or put new executables on a target. So if you're in coastal waters and we have a lot of land, which we see, and mountains and birds, it requires a different kind of processing than when you're on the middle of the ocean, when there are only waves, and maybe an albatross or one, but not many birds. Yeah. So you can reason about it. That's a big advantage of this architecture. And then we go to system level, where you go about across infrastructure, and it is distributed, and you see about the security. Security is another point where in the past we have static security solutions. And if you have an adaptive system, you're not aware of the security, the cyber attacks you're going to get. So you have to be completely adaptive.
So this is also one of the topics you're discussing with universities, right?
Yes. Yeah.
Exactly.
Yeah. So you have to have an adaptive security solution. And it's a bit of a contradiction on the current security solution. So if we don't have a solution there, we only know we're not going this direction. Stay on Mount Stupid from the current security solutions, I would say. So I dare you. And then on the solution level, it comes back to the coordination of our systems, that you build systems because you have an intent. You want to do something with the system. Our customers have an intent. They want to protect things. And this intent can change. This intent, so you have an intent-based coordination, which you can change the complete functionality of the system. And you can reason about this in a dynamic way. So this is just a part of the architecture we thought of in ethics. And you see here that it's going back to layers, modularity, all the stuff that the old Jedis predicted.
Yeah, exactly.
And we built a reference implementation of this architecture, which we're using now currently in our current systems that we built now for the 2025. So in 2025, the new M frigates from the Dutch Navy, Dutch Marine Navy have to
be based on this architecture.
Based on this architecture, but this also means that we're unable to predict what the technologies are current in 2025. Yeah. So the least thing we want to do is stick to certain technologies, but just plug in new technologies when the time is right, and when we are able to plug technologies.
Yeah, which brings me why we're here.
Yes.
Exactly.
That's why we're here.
Yeah.
So this is the part where we switch to Dutch, I think.
Yes.
So, we gaan in Nederlands verder, omdat wij zien dat dit niet alleen een probleem is wat Luminis en Thales aangaat. We zien dat het een probleem is wat eigenlijk de BV Nederland aangaat. We moeten ons onderscheiden van de rest van de wereld. Van Mount Stupid af, aan de rechterkant naar beneden. Kijken wat is er van wijsheid in de wereld die we kunnen gebruiken. En onderscheiden dat we daar fouten kunnen maken en dat we in staat zijn om die fouten te herstellen. Ja. Dus ik zou jullie willen vragen, we gaan niet weer staan, maar dat hebben we al 2 keer gedaan. Ik wil eens vragen van, herkennen jullie Mount Stupid? En kunnen degenen die van jullie op Mount Stupid hebben gestaan, of nu zitten,
ja, durf die hand op te steken.
Is de hand opsteken.
Ja, precies.
Ja, neem de tijd.
Ja.
ja, toch een aardig aantal. Dus degene die nu de hand opsteken, willen we vragen, ook degene die niet de hand opstaken, maar degene die de hand opsteken, willen toch vragen van, denk met ons mee. We hebben hier een begin gezet, een aanzet gemaakt.
Dus Andati.org en Inetix.org, dat zijn open source projecten. En als je aan die rechterkant van Dunning-Kruger wil komen, dat gaat over samen. Dat gaat om waar we hier bij elkaar zijn. En dit is een basis waar we een aantal inzichten gecodificeerd hebben in architectuurdocumenten, in software assets. En het is goed om daar meer mensen op aan te sluiten. Dit is een uitnodiging. Onze mailadressen zijn erop. Dus mocht je meer willen weten, drop hem een mailtje.
Ja.
Dank jullie wel.
Dank je wel.
Ja, heel goed.
Thank you, René. Thank you, Hans.
Thank you, Niels.
Hans Bossenbroek and René van Hees. And also I would like to thank our other speakers, Sam Aaron and Rudy van Buren. And please take the opportunity later this day to visit Rudy at his simulator booth, where you can learn more tips and tricks. But not only that, also you can learn something about the technology Luminis used for the world's fastest gamer eSport competition. And please make contact to each other. Create magic together. And to close this part of the day, I have one final experiment. And therefore, I would like to invite a lady and a man together on stage that don't know each other yet. Can I have a little bit more light? Thank you. Was it that lady? Would you like, yes? Would you like to visit me on stage? Thank you. And this man with the shirt, the green shirt. Thank you. And of course you get a round of applause. Hi.
Hi.
Niels.
Tos.
Tos?
Yeah.
Tos. How many times you visit Luminis DevCon?
No, this is the first time.
This is the first time. So you're a DevCon virgin.
Yep.
Yep. Hi.
Hi. Heike.
Heike.
Yeah.
Also your first time?
Yes.
2 virgins. Heike, would you like to stand here for a second? And Tos, would you like to stand here for a second? And Tos, well, yes, I would like you to stand like this, on profile for the people there. And Heike, a little bit like this. Thank you. And Heike, if you would be so kind, pull up your sleeve a little bit.
Yep.
Thank you. And for you, please the left hand, do it like that. And you, okay. Now, getting contact with each other is not only about talking with each other, but making real contact together. I have one question for you, please. When the experiment starts, and I will point out to that point, please be aware everything you see. And for you guys, it's important that you be aware everything you feel. You will enter this experiment with your eyes open. You will enter this experiment with your eyes closed. But I promise you, you're here completely okay now. They're all bodyguards. Are you ready for the experiment? Mm-hmm. Heike, are you ready for the experiment? Yeah. Please be aware of everything you feel, because it can be light as a feather. Okay? Okay, open your eyes, close your eyes. Stay concentrated. The person who felt in this experiment something on the stretched arm, please raise the other arm. And if you felt something, please with the other arm, try to touch the point where you felt something. Okay. If you felt something on your face in this experiment, please raise your hand again. And try to touch the place on your face. Interesting. And maybe one last chance. If you felt something on your back in this experiment, please raise your hand. Now, put your hands down and open your eyes. One question. You felt something on different parts of your body?
Yep.
Okay. The first part was the
arm.
Arm, and the second?
My nose.
Yeah. And the third part?
Was my back.
Your back. Yeah. And you felt also something where?
Yeah. First the arm, and
face.
then the face, and then the back.
Can you stand all for a second? And please be really honest, especially to Heike. Because please point out the only person on stage that I've touched in this experiment. Please do it now.
I thought already, yeah.
I didn't touch you, but they caught it on camera, so maybe you have to watch it again. And if I didn't touch you, I feel here's coming a Me Too point. Then he's the guy who's touched you. Thank you very much, Tos. Thank you, Heike. Thank you. Drink something together. Guys, I wish you a lot of inspiration this day and also, and maybe more important, a lot of magical context this day. Don't forget to vote on all the sessions, all the speakers. They much appreciate that. And I hope to see you once more, maybe in Bonaire where we're eating meatballs. Bye-bye.